the same through insula. We will see inside of hemisphere basal nuclei. They are, that is thalamus, and in front from thalamus, that is caudate nucleus. It is head of caudate nucleus. Then lentiform nucleus. And these two nuclei, that is first basal nucleus, corpus striatum. Why we speak about two nuclei combined in one name, corpus striatum? Because if we continue to make, to cut brain, in ventral part of brain, caudate and lentiform nuclei join together. And this white matter between them, it has name internal capsule, it's disappear. Caudate and lentiform nucleus fuse together. And in dorsal part, they separate with the help of internal capsule. That is why it is first basal nucleus, corpus striatum. And it consists of caudate and lentiform nuclei. And nucleus lentiformis subdivides into three parts, and these two parts, inner part, that is globus pallidus, and lateral part, that is putamen. That is first nucleus, corpus striatum. Outside from putamen, we have narrow part of gray matter, that is claustrum, number 6 at my diagram. Claustrum. And laterally from claustrum, that is cortex of insula. This is cortex of insula, laterally. Cortex of insula. Between putamen and claustrum, we have cortex of insula, that is number 7. Number 8, that is internal capsule. Number 9, external capsule. And white matter between claustrum and cortex of insula, number 10, that is capsula externa. Capsula extrema, sorry. Number 9, capsula externa. And capsula extrema, that is most lateral white matter. Number 11, that is thalamus. And internal capsule has conductive tracts, and I continue to describe these tracts in a minute. Now, how many nuclei we draw in this diagram? First, that is corpus striatum, and second, that is claustrum, only 2 basal nuclei. Third basal nucleus, impossible to see in this diagram because it is in ventral part of temporal lobe. Inside of temporal lobe, we have third basal nucleus, it is amygdaloid body, corpus amygdaloidum, amygdaloid body. That is why 3 basal nuclei you should know next time, and 2 of them present in this diagram. Next, white matter. White matter in hemisphere consists of 3 types of fibers. First, that is associated fibers. These fibers in the region of hemisphere. And second type, that is commissural fibers. They join together right and left hemisphere. And projectional fibers between hemisphere and another departments of brain and with the spinal cord. Between hemisphere and another departments of brain and spinal cord. Associated fibers consist of short and long fibers. Short fibers between nearest gyri, joined together nearest gyri. They are fibra arcuata cerebri, arcuate fibers, and long associated fibers. For example, between frontal, parietal, and occipital lobes, we have superior longitudinal fascicle, fasciculus longitudinalis superior. Between temporal and occipital lobe, inferior longitudinal fascicle. between frontal, parietal, and temporal lobe. We have fasciculus uncinnatus. Uncus, that is hook, hook-like fascicle. Fasciculus uncinnatus. And inside of gyrus fornicatus, this yellow gyrus, gyrus fornicatus, we have white matter. It has name cingulum. It was associated. Now, commissural fibers. Commissural fibers, they joined right and left hemisphere. And largest commissural fibers, that is corpus callosum. Corpus callosum joined the same structures in both hemispheres. For example, gyrus praecentralis in left hemisphere through corpus callosum joined with gyrus praecentralis on the right side. Postcentral gyrus with postcentral. Superior parietal lobule with superior. Inferior with inferior. Clear? The same structures in one hemisphere joined with corresponding structures in opposite hemisphere through corpus callosum. And corpus callosum consists of knee of corpus callosum, that is genu corporis callosi, and knee continues into rostrum. Here it is rostrum corporis callosi, which is attached to lamina terminalis. If you remember, last time in hypothalamus we described lamina terminalis. Rostrum corporis callosi, then trunk, truncus corporis callosi, and posterior white part, that is splenium corporis callosi. Next commissura, that is the same, you already know, commissura cerebri anterior. We described it last time when we speak about anterior wall of the third ventricle. This commissura cerebri anterior, is joined together olfactory lobes, bulbus, tractus, trigonum, olfactorium, and substantia perforata anterior, joined with the same structures on opposite sides through commissura cerebri anterior. And last commissural fibers between right and left fornix. Look here, that is fornix. Posteriorly, fornix continues into crura fornices, that is continuation, crura fornices. And crura fornices goes to hypocamp and makes fimbria hypocampi. And now, left and right crura fornices join together with the help of commissura fornices. Commissura fornices. This commissura join together left hypocamp with right hypocamp. Three commissural fibers, corpus callosum, commissura cerebri anterior, and commissura fornices. Projectional fibers, last type of white matter. Projectional fibers, all projectional fibers pass through internal capsule. And internal capsule consists of anterior crus between head of caudate nucleus and lentiform nucleus, and posterior crus between thalamus and lentiform nucleus, and between them, that is knee of internal capsule, genu capsula interna. Anterior crus has two tracts. Letter A, that is tractus corticothalamicus, or another name, tractus frontothalamicus. That is the same, as you want, frontothalamicus or corticothalamicus. Letter B, tractus frontopontinus. If you remember midbrain, in midbrain here was frontopontinus. Who remember what is the name of this tract in base of cortica nuclearis? And here it is letter C, that is the knee of internal capsule, tractus
corticospinalis.
Cortica nuclearis.
Okay.
Next is
Spinalis.
tractus corticospinalis, it is letter D. Then letter E, that
Frontalis.
no. Listen to me, it is new for you. That is tractus thalamo-corticalis, between thalamus and brain cortex. Tractus thalamo-corticalis. Letter F, tractus
Frontalis.
accipita tempora, parietal, pantinus, it was here. Then central, letter G, central auditory tract, and letter H, central optic or visual tract, that is radiatio optica here and radiatio acoustica, letter G. They are at the end or posterior part of internal capsule, posterior cruise of internal capsule. This diagram, they are basal nuclei together with internal capsule. An internal capsule has projectional fibers. Next, lateral ventricle. Lateral ventricle, that is cavitas of telencephalon, and it has three horns. In frontal lobe we have anterior horn, in parietal lobe we have central part, in occipital lobe posterior horn, and in temporal lobe here, that is inferior horn. Anterior horn, medial wall of anterior horn, that is transparent septum, septum pellucidum. Septum pellucidum, that is a border between anterior horn of left lateral ventricle from anterior horn on the right side, and it is medial wall. Lateral wall of anterior horn, that is head of caudate nucleus, and superior wall, that is corpus callosum. In central part, pars centralis, inferior wall, that is dorsal surface of thalamus, and laterally, that is body of caudate nucleus. Superior wall, one again, corpus callosum. Posterior horn in occipital lobe, and on medial wall, it has eminence. This eminence has name calcar avis. This calcar avis, that is eminence from this groove on the surface, it is sulcus calcarinus, and this sulcus makes eminence calcar avis. And superiorly tapetum, that is fibers of corpus callosum. Inferior horn on superior and on anterior wall, it has tail of caudate nucleus. Medially, that is hypocamp together with fimbria hypocampi, and inferior wall of inferior horn, it has eminence from sulcus collateralis. This groove on the surface makes eminentia collateralis in inferior horn. Eminentia collateralis. In lateral ventricle we have plexus choroidus, because choroid artery goes to this horn, it goes to inferior horn and then continues to whole ventricle. And cerebrospinal fluid flow from lateral ventricle goes to third ventricle through what? Foramen interventricularis. From third ventricle, cerebrospinal fluid goes to cerebral aqueduct, comes to fourth ventricle, and one way from fourth ventricle, that is into the central canal. But central canal, it finishes with terminal ventricle, it is blind structure, and cerebrospinal fluid not leaves spinal cord. That is why cerebrospinal fluid from central canal goes back to the fourth ventricle, and how it leaves fourth ventricle? Through what? Three apertura. Apertura lateralis ventriculi quarti and apertura mediana. Three openings on the roof of the fourth ventricle, and through these three apertura, cerebrospinal fluid goes to subarachnoid space. And how cerebrospinal fluid leaves subarachnoid space? Central canal? No, it goes into the sinuses. In a minute. Look here, that is vertebral column, vertebral canal. That is spinal cord. spinal cord. And what is external cord? That is dura mater. Here it is arachnoide, and here it is pia mater, which is attached to the spinal cord. What is the name of space between dura mater and vertebral canal? Epidural space, yes. And what present in epidural space? Venous plexus and fat. And between arachnoide and pia mater, that is subarachnoid space, and here it is cerebrospinal fluid. Now, bones of the skull, that is roof of the skull. Here it is dura mater, and that is it. It makes phalanx cerebri.